Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 8, looking at lessons 12 and 13, solving systems with elimination. So we've been looking at these systems of equations. We've talked about graphs of systems. The solution is the intersection point. We've talked about using what's called the substitution method, where we can substitute one of the variables in order to solve for our solution to the system of equations. Today we're going to look at a method called elimination. And in our last lesson, we started to look at some of the pieces that we would actually be using to use this elimination method. And so basically elimination, you have the definition there. It says it's scaling one of the equations in such a way that when it's added or subtracted to the other equation, one variable will zero out or be eliminated. And so if we look at this first example, we have a system of equations, and it asks what should the second equation be multiplied by so that x is eliminated. So if we want to zero out or eliminate this x variable from this system of equations, what would we need to multiply that second equation by? Well, if this equation is 6x, when I add these equations together, I would need this to be negative 6x in order for that variable to zero out. And so to make this 2x into negative 6x, I would need to multiply that entire equation by negative 3. And so if I take a negative 3 times 2x, I get negative 6x. Negative 3 times positive 3y would be negative 9y. And then negative 3 times negative 14, that would be a positive 42. And so then I could add this first equation and my new equation together. And when I do that, my x variable would zero out. So negative 3, or I could say that I could multiply it by positive 3. If I use positive 3, then that means that I have to subtract those two equations because it would be 6x minus 6x to get to that 0. So either of these would be acceptable, but usually we're going to say whatever we would multiply so that when I add those two equations together, it zeroes that out. All right, so my second one here, we're actually going to use that elimination method and we're going to solve for what our solution point would be. And so looking at my variables, the x, the y, the easiest one to eliminate here would be the y because I could multiply that negative 2y by 2, and that would give me negative 4y, which when I add these together would zero out. So I'm going to multiply this equation by 2. So 2 times 9x is 18x. 2 times negative 2y is negative 4y. And 2 times negative 18 is negative 36. And now I'm going to add these two equations together. So I've multiplied that by 2 to get this one. So now when I add these equations together, 2x plus 18x is 20x. 4y plus a negative 4y is 0. So those eliminate or zero out. And then 16 plus a negative 36 would be negative 20. And now I can solve this for x. The y variable's been eliminated, so I divide each side by 20. And x would equal negative 1. So now I know that negative 1 is the x coordinate of my solution. Now I want to find what y would be. And so I'm going to plug that negative 1 into one of those equations in place of x. So I'm going to take the second equation, 2 times negative 1 plus 4y equals 16. And now I want to solve this for y. Well, 2 times negative 1 is negative 2. So negative 2 plus 4y equals 16. I want to get variable by itself here, so I'm going to add 2 to each side. And that gives me 4y equals 16 plus 2 is 18. And then I'm dividing each side by 4. 18 divided by 4 is going to be 4.5 or 4.5. And so that tells me that my solution point, that's the y value, -1 was the x value. That's the solution to this system. And basically what that solution is saying is that if I plug in -1 for x and 4.5 for y in both of those original equations, it's going to make those true. All right, one more problem here. Let's scroll down to this last one. We're going to solve this one as well using elimination. So looking at our variables, notice that the y's, there's not something I can multiply one equation by. I'd have to multiply both of them. But on that x variable, if I multiply that first equation by 3, it would be 9x here. So I'd have 9x and -9x, which would zero out. So I'm going to multiply this equation by 3. 3 times 3x is 9x. 3 times -5y is -15y. And 3 times 4 is 12. And now we're adding these equations together. So -9x plus 9x, that's 0. So the x has eliminated. -3y plus -15y is -18y. And then 24 plus 12 is 36. And then to solve for y, I'm going to divide each side by that -18, undoing that multiplication, and we get that y equals -2. All right, so that is the y value in our solution. We need to find the x value. So we are going to plug that in for y in, I'm going to use that second equation. So we're going to plug in -2 for y, and now we can solve this one for x. -3 times -2 is a +6. So we have -9x plus 6 equals 24. We'll subtract the 6 from each side to isolate that variable. So we're left with -9x equals 18. And then finally, we're dividing each side by -9. And we get that x equals -2. And so in this case, our solution point was -2, -2. And again, what that means, if I plug in -2 for x and -2 for y in each of those equations in the system, it's going to make that equation true. All right, and that's all I've got for you today on solving using elimination. As always, if you do have questions, please let me know. Thanks. Have a great day.